We're going to go over rate of change. We have a rocket that is modeled by this function. Okay, so its flight path is what looks like a parabola. And we want to know the rate of change when t, standing for time, time is 4, so 4 seconds. Okay, so we want to find, let's say if this was our t at 4, we would be looking for our tangent line at this point. Okay? Now if you recall, for rate of change, that's the change in y over the change in x, which was, as we'd written before, a plus h, the function of a plus h. Sorry, it's subtract, yeah, not plus. Subtract over h. Okay? So I'm going to try to organize this a little better for you. And actually what we're going to do is we're going to actually find the equation of that line when it's tangent at 4 too. Okay? Just because you might need to know that. So we have our function. F at a is essentially what we're looking for is our y value when we plug the value of 4 into this equation.
42.
Okay? Oh, did you already get it?
Yeah.
Okay, so f at, I'm going to do each step just so we know. But f at 4, which is essentially our f at a in this question, is equal to negative 5, 4 squared plus 30 times 4 plus 2. Excellent. And you said it was?
42.
42. Excellent. So we're going to replace our f at a. We'll highlight that in blue. With our value of 42. Now the trickier part of this is our a plus h. Now a is the value of 4. Okay. So now we're going to be finding, do it in green, f at 4 plus h, because we already knew replace the value of a with 4, that's the coordinate we're looking for, into the exact same equation, negative 5, 4 plus h squared plus 30 times 4 plus h
Oh, yeah.
plus 2.
Yeah.
Okay. So we're going to take these values out. This becomes h squared plus 8h plus 16 plus 12 plus 3h plus 2. Then becomes negative 5h squared minus 40h. 30, 80, negative 80 plus 12, 3h plus 2. So we're going to simplify this on the side so that when we go to plug it in, it's simpler.
Plug in h. What is
We're going to
h?
be plugging in this value. H is going to be 0 in this question, a very, very small value, because we're looking for an instantaneous rate of change. We're looking for a rate of change at 1 point.
Plug that in the beginning, so it's just like f 4.00.
Why didn't we just plug in h at the very beginning of 0? Because we have 0.
No,
and 0.
0.0001.
It's essentially 0. That's the
Wow.
idea. Okay. The idea is it's essentially 0. So we go ahead simplifying this. We have negative 5h squared. That was a good question, though. Negative 40 plus 3 is negative 37h. And this is going to give us 1466. Is that right? We think so?
Yeah.
Yeah? We're okay with that? Okay. So if this being the case, it seems like odd numbers. We can pull 5 out. No, no. Okay. So let's plug this in. This is our value for f at a plus h. So recall the formula said we're looking for the change in y over change in x, which is f at 4 plus h minus f at 4. And our f at 4 value, I feel like there might be an error along there somewhere. I'm going to check that actually. We briefly looked through it and we discovered that this shouldn't have been 3 but the value of 30, which changed this to 30 and this to 120, this to 30, which then made our middle term negative 10. And it makes our final term 42. And like we said, we need this value to be 42. And we'll talk about why in a second. It is going to be positive. Yes, it is. Thank you. It's positive 42. And as we go through this, we'll talk about exactly why. So this is all over the value of h. So we go to plug this in because this is f at 4 plus h. We're going to take this value and plug it in. And we know f at 4 was the value of 42. So we go to plug that in. We have negative 5h squared minus 10h plus 42. And then subtract, because it's a subtraction sign, f at 4, which is 42, over our value of h. So I knew I'd made an error before because the goal here is we need to be able to cancel out these constant terms. So when these constant terms are now 0, I can take a common factor of h out, which will allow me to eliminate that h. So when we take this h out, in fact, we can take out negative 5h. We're left with h plus 2, okay, all over our value of h. We can eliminate our two h's. We have negative 5 times h plus 2. Remember, we were still looking at this as a limit as h as it approaches 0 because it's instantaneous. We're looking for a rate of change at a specific point, so we're hoping we're getting closer and closer to the value of 0 for h. So that means our limit at this point, when we plug in 0, should be negative 10. So the rate of change at this point in time is negative 10. We're not done. Remember I said I wanted to do the equation, right, at t at 4. Well, we know that coordinate at 4 is 4 and 42. Let's scroll down here. When we plugged in 4, we got a coordinate of 4 as our x value and 42 as our y. And we know the rate of change is for a tangent line, a linear line, which means this is sloped to some line. This line being y equals mx plus b. This negative 10 represents the slope of that line at that point. So we have y is equal to negative 10x plus b. And we want to solve for the equation of the line. So we're looking for our b value. Well, we need a coordinate to plug in, x and y. So we're going to plug those values in for the x and y in this question. So our y value is 42, is equal to negative 10 times 4 plus b, which gives us 42 plus 40. Yeah. Our b value being 82. So the equation of the tangent line is y is equal to negative 10x plus 82. That would be the equation of the tangent line at the point of 4.